Thus, this 100 factorials is simplified in prime factors. Prime factors means prime numbers. We need here, in order to get number of zeros, 2 power p into 5 power r. These are important. How can you find the p and r? These are the numbers. Finding, you see, here is a very important concept. Finding p, that is power of 2. Okay now? How can you find? You see, it is a step 100 by 2 plus step of 100 by 2 square plus step of 100 by 2 cube, step of 100 by 2 power 4, step of 100 by 2 power 5, step of 100 by 2 power 6. There it ends. Why? Because 100 by 2 is 50, step 50 plus it is a step function of 100 by 4 is 25. It is 100 by 2 cube is 8. It is 12 point something, not needed. It is 100 by 16, 6 point something, not needed. It is a step of 100 by 32, 3 point, it is 3 point some digits. 100 by 64, it is 0 point something. 100 by 64 is 1 point something. 1 point something. And the next is 100 by 2 power 7. 2 power 7 means 128. It is 0 point something. Okay now? You see, the step function, the integral, greatest integral function of 50, it is a full integer. It is 50 and this is 25 and it is 12 only. Only integer we have to take. Here also 6 only. The remaining fraction will be deleted. It is 3 plus 1 plus 0. That means it is 97. Okay now? So there are 2 power 97. I will write again. Similarly, finding r, not 3 power q is not needed. Only 2 and 5. R of 5. The power of 5. It is also the step function 100 by 5. It is step function 100 by 5 square. The step function 100 by 5 cube and so on. It is not needed. The remaining, because 100 by 5 is how much? It is 20. Step 20 is 21. 100 by 25 is 4. Here 100 by 125, 5 cube is 100 by 125 is 0 point something. So it is 0. So we get 24. Okay now? So here P is equal to 97 is greater than R is equal to 24. What I told you already we discussed. P is greater than R. So there are number of zeros. The number of zeros is 24 zeros are there. In that expansion 100 factorials, some digits will come and the last 0, 0, 0, 0, 0 like that 24 zeros are there. That is the answer to this question. You follow this one. But it is not needed to do all these things. Just in order to know the concept. You see, very simply by using the Tondy method, I will tell you. Here the Tondy method is very simple. You see, 100 factorials. For 100 factorials, we have to find the number of zeros. That is 100 by 5. What is 100 by 5? Is 20. And this 20 this 20 again divided by the 5 one, only 5 is equal to 4. Okay, na? And this 4 can also be divided by 5. It is a fraction. So it is you write it as a 0. Here 0 integer 0.8. So it is 0 only. Okay, na? Try to understand. Here it is 4. It is 20. So the number of zeros is 20 plus 4 plus 0 is 24. Okay, na? Like this. Okay, na? Right. And one more thing. One more example, we will solve it. The same question. Number of zeros in 5,000 factorials. But 5,000 factorials, only factorials I have to take. The answer is 5,000 by 5 only. That is 1,000. I am using the Tondy formula. And this 1,000 again divided by 5. It is 200. Yeah. And this 200 again divided by 5. It is 40. And this 40 again divided by 5. It is 8. And this 8 is again divided by 5. It is 1.6. 1 time 3 remains. 3 means 30 by 5 means 6. But we have to take it as only 1. Here it is 8. Here it is 40. It is 200. And it is 1,000. How many zeros? Number of zeros is equal to 1,000 plus 200 plus 40 plus 8 plus 1. How much? It is 1,200. 1,249 zeros are there in this expansion 5,000. Okay, Nana? Like this. Okay. Now, nice one. Suppose the number of same concept, but a twist is there. So number of zeros in the expansion. The expansion of 100 factorials by 50 factorials is there. How can you find? By division is there. You see, we know that in 100 factorials already we solved how 100 by 5 is 20 and that 20 by 5 is 4. So 20 and 4 is 24. Similarly, 50 factorials. In 50 factorials, you see, it is 50 by 5 is 10 and that 10 by 5 is 2. Okay, now there it ends. It is 10 plus 2 is 12. Okay, now the number of zeros in the expansion is, if division is there, we take the subtraction of these two numbers. It is 12. There are 12 zeros. Suppose the same question, the number of zeros in expansion of 100 factorials into 50 factorials. Already we know it. 100 factorials is with 24 zeros plus 50 factorials is 12. So it is 36 zeros are there. If division is there, we make a subtraction. Product is there, we make the summation. Okay, na? Like this. Okay, na? Pass. Okay. Now 10th problem. 10th formula. Okay, na? Observe. It is the digit in units place of expansion one factorial plus 2 factorials plus 3 factorials plus 4 factorials 5 factorials 6 factorials and so on 100 factorials. You see, it is also a confusion problem, but it is also asked in the exam. Solution. You see, 100 factorials, 99 factorials, and so on up to 6 factorials, 5 factorials, 4 factorials, 3 factorials plus 2 plus 1 factorial. You see, 1 factorial is 1, 2 factorials is 2, 3 factorials is 6, 3 into 2 into 1, 4 factorials is 24, 5 factorials is 120, 6 factorials is 720, 7 factorials is 50, 40. Okay, na? So here 0 comes. 8 factorials again 0 only. It may increase here only. The first unit place is here it started. In the 5 factorials 0 is started. 6 also 0. 7, 8, 9, 10, whatever it may be the number. It is going on increasing, no doubt. In the units place 0 only is there. It is a fiction. No need to worry. Whatever it may be. It is always 0. So, like this, we get in the units place 4 plus 6, 10, 2 plus 1, 13. Okay, na? And whatever it may be, in the tens place, and 100 place, 1000 place, 10,000, whatever it may be. 3 is in the units place. Okay, na? You see there. 4 plus 6, 10 plus 2, 12 plus 1, 30. So here we get the answer is 3. So 3 is in the units place. Okay, na? Right. Just we change the chapter. Straight line. Welcome to the chapter straight lines. You see, distance between parallel lines. Ax plus by plus c1 is equal to 0. And Ax plus by plus c2 is equal to 0. Is the distance between the parallel lines is mod of c1 minus c2 by root of a square plus b square. Of course, this concept is there in the regular exam. I mean, the regular syllabus. You see, here you find the difference A and B of X and Y coefficients are same. Why? Because they are parallel lines. Only the difference is in between a C and a C2, C1 and C2. That is constants. That is the formula. The distance between parallel lines. Similarly, here, equation 2. It is equation 2. Midway line between parallel lines AX plus BY plus C1 is equal to 0 and AX plus BY plus C2 is equal to 0 is observed. It is simply AX plus BY plus C1 plus C2 by 2 is equal to 0. Don't confuse. You see, the concept is, I will draw the diagram here. Observe me. Suppose there are two lines. This line is AX plus BY plus C1 is equal to 0. And this line is the same AX plus BY plus C2. Only the difference is in the constant. The midway line between these two parallel lines, it is lying in between the two lines. It is also parallel to these two lines and it is in the middle way. So it is a midway line. It is called as a midway line. Its equation is simply AX plus BY plus C1 plus C2 by 2, like this. Suppose an example. The lines are 2x plus 3y plus 5 is equal to 0 and 2x plus 3y plus 7 is equal to 0, like that. Is there the midway line? Midway line is observed. It is 2x plus 3y plus 5 plus 7 by 2. Okay, that is equal to 0. That implies it is 2x plus 3y plus 6 is equal to 0. Okay, that is the midway line. Yeah. Okay. Okay. Yeah. 12th formula. Suppose A x1 comma y1 and B x2 comma y2. These are two given points and the line segment of these 2 points is divided by a line L identically equal to AX plus BY plus C is equal to 0. It's a line that cuts the line segment AB joining the 2 given points. Line equation is given and points are given. And we are asked to find in what ratio, in which ratio the line cuts the line segment A. That is the question. So here AM by BM, that ratio is equal to minus L11 by L22. L11 means the line equation is substituted by the point A, first point, 1, 1, 1, 1. L22 means the line equation is substituted by the second point, 2, 2. Okay, now it is minus. Why? Because we leave it out, that is proof. Minus L11 by L22. That is the ratio in which the segment is divided by the given line. If it is greater than 0, if it is positive, total this one is positive, points A and B lie either side or both sides. Okay, na? Both sides. That means it is positive, means the ratio is positive. 2:3 means that point divides, or it is in middle, not midpoint, it is in internal. For AB, the line is internal. Then the ratio is positive. Whereas the same thing is negative. For example, if it is negative, if you get a negative value, that the points A and B lie on the same side. Okay, na? Same side means, for example, here it is A and it is B. The line is like this. Here M. Here the point at one side one. Okay, na? At one side one. AB at one side. The line segment externally divided by the point by the line at M point. But here it is internal. If it is internal, that is it must be, this ratio must be greater than 0. If it is negative, that means it cuts the line segment AB externally. That is the difference. Okay, now, for example, again give an example. You see, we clearly I will tell you. It is a horizon and it is the point here, it is 2, 0, and it is B, it is 7, 0, just like it. Very clearly I want to put it. Suppose a line is like this. This is a line x is equal to 5. It is x is equal to 5. That means L is equal to 1x 0y minus 5 is equal to 0. You agree? Yeah. This is x1 y1. This is x2 y2. Okay, now let it be m. We need am by bm. It is minus L11 by L22 na. Minus, what is L? This is L, equation of line. L means equation of line. This must be satisfied by this point. That means 1 into 2 na, or x, 2x1. Plus 0 into 0 na, y is 0. Minus 5. By 1 into the second point, 7 na, plus 0 into 0 na, minus 5. So it is 2 minus 5 by 7 minus 5. It is minus 3. 3 by, this is how much? Okay, na? This is 2. Okay, na? So AM by BM is 3 by. That means the ratio is AM is to BM. That ratio is 3 is to 2. Here it is positive. This ratio is automatically positive. Okay, na? Minus of minus 3. Here 7 minus 3, very particular. 3 by 2 is a positive number. So if it is positive, it is internal. Yes, it is internal. Okay, na? Like this we can prove it. Okay, na? Right. Pass.